Assalamu alaikum, dear students. This is O-level physics chapter 1, and we are dealing with the measurement. And as far as the measurement is concerned, the last two lectures were based for the ruler scale, and the other was for the vernier caliper. Today we are dealing with another measuring instrument, which is a screw gauge. Here you can see first of all the structure of the screw gauge, and there are a few points which we have to remember as far as the structure is concerned. Here we have the main scale. This is your main scale here, which is fixed, and here you have marking in millimeters. So this is your main scale. Here you have a line. This line is known as datum line, and here you have other part like this is your circular scale, and this circular scale is marked with division, and normally we have 50 divisions on this circular scale. Basically, what is the purpose of circular scale? So simple thing is that the main scale reading will tell you the basic reading, but when you will have a reading like suppose 5 point something, so what something or what fraction you have to add in your reading, this will come from this part, which is the circular scale thing. Here you have another part which is termed as ratchet, and this is your ratchet here. Yani you can move the screw. Basically the screw gauge is something which is based on the function of a screw. So here you have a complete screw here inside, and when you will move the ratchet, the screw will move in or out, and then of course you can use this spindle, and here you have the anvil, and in between these two, anvil is basically a fixed part, same is the frame is the fixed part. If you will mark, like suppose if you can use another color, so suppose this is something which is fixed, and this is also the fixed part, which is the frame of your screw gauge, and basically you will hold this screw gauge with the help of this frame thing. So this is what we have. As far as the spindle is concerned, you can see that the spindle we can move, and of course the spindle is attached with the screw inside the main scale. So this is how you will get the you can say idea about the structure. As I said that when you will consider this part is basically coming from the screw, and here of course you can take another color, suppose this color, and this is your spindle. So when you will move your ratchet, or even sometimes you will see that you are holding this thimble or moving this thimble, so this thimble will move in or out, and then you will get the reading. How we will get the reading we will see, but this is the structure. Quickly recall what we have studied. One is the main scale. This is your main scale. Here you have this circular scale. Basically this is the circular scale you have, and this part is termed as the thimble, and on the other hand you have ratchet, and this is connected with inside, you can say, the main scale. There is a screw which is moving in and out. On the other hand, anvil is fixed with frame, and your spindle is connected with the screw, and you can move this spindle in and out when you will move this ratchet. So I will show you the animation as well, so you will get a better idea. As you know that we have a term least count. If you have studied, or if you have gone through my last two lectures, then you can see that what is the least count. But as far as simple definition of the least count is concerned, this is the least value you can measure, least length you can measure, or least value you can measure with the help of any instrument. In this case, the least value is 0.01. So this is the least count here. This is the least count, like 0.01 millimeter is the least count. Now the thing is that how you will take the reading of anything, like suppose if you have here the measured object, or the object for which you want to get the reading. Here you have suppose a simple screw or a simple metallic sphere, and you want to know the diameter, or ultimately you can even calculate the radius, but of course basically you will calculate the diameter. So how you will take the reading, this is very important. Here you can see we have certain points already written here, but quickly go through. Of course, first of all, you will fix the object in between the anvil and spindle by moving or turning the thimble. And of course, when you will fix this object in between the anvil and spindle gently, do not press beyond the limit, otherwise you will hear a click and it means that you are over pressing this thimble thing. So don't do this. Here when you will have a situation like this, a fixed situation, so you can read the main scale. In this case main scale is 4.5. and how you will check this? Here you have to see where is the edge of your circular scale. So the circular scale is just behind the reading of 4.5. So you will consider the main scale reading as 4.5 millimeter. As far as the observation column is concerned, you can draw a column like this. I have drawn here, and in your first reading, if you are measuring the first reading or taking the first reading, so what is the value here? So simply you can say that main scale in millimeter is 4.5. But as you can see here that the reading is more than 4.5, but because still we don't have 5, so what is the fractional part? So to get the fractional part, you will see the circular scale. So here you have the circular scale. In this case, of course, this is the circular scale. But here you have to check that which line or marking of your circular scale is in line with the main scale line or datum line. Again, the datum line is fixed with any marking or division of your circular scale. That will be the value of circular scale. So in this case, what is the value? 10, 11, 12. So simply you can say that the circular scale reading, which is in division, is 12. This is in division, be careful. Now to get the fractional part, what you have to do, you have to multiply this value by the circular scale division. So you will get the reading in millimeter, 0.12 millimeter. Now here you have the value of 4.5 main scale reading. Here you have the value of the fractional part. Basically fractional part is nothing but circular scale reading in millimeter. Be careful. This circular scale reading which you are measuring directly is not in millimeter, but it is division. So it's divided into divisions, you can say. So ultimately what you have to do, for each circular scale reading, you will multiply this circular scale reading with the least count, which is 0.01 millimeter, and then you will get a value which you can add here. So 4.5 0 plus, even you can write here 0 plus 0.12, this will be your reading 4.5, 4.62. So this is what we have here. This is your reading, main scale reading. As I said, first what you have to check, where is your circular scale edge, and the reading on the main scale just before this will be the main scale reading. For circular scale reading, you have to check where your main scale, datum line of the main scale coinciding with the marking of the or division of the circular scale. That will be the value of your circular scale in millimeter. Here we have written directly, this will be the calculation which I have mentioned here. And ultimately when here basically, so when ultimately you will get the answer, this is something like this. So 4.5 plus minus plus 0.12, which is 4.62. So this will be your value, which is the total reading. Here we have another concept. I think you have understood what I have explained. Main scale reading, edge of the circular scale. Just before the value or just before the edge, the value of the main scale will be your main scale reading. for I am just repeating the whole thing. The datum line of the main scale is coinciding with the circular marking, and that will be your circular scale reading. And of course, what you have to do, as I said, that circular scale reading is not in millimeter, but it is in division. So what you have to do, you have to multiply each value by the least count, and you will get this value, and then you have to add these two to get the value of 4.62. This will be in millimeter. Now here we have a concept, as we have discussed in vernier caliper as well. There are possibilities of zero error. What is a zero error? I am just using the slide here, taking from your physics book, and here you have the journal physics, which is giving you this whole story. Here you can see that when the zero marking of your circular scale is coinciding with the zero of the main scale, then you will say that there is no zero error. The two zeros marks coincide. There is no zero error. And whatever the value you have, like here in this case, you have the reading 5, 6, 7, 8, 8.5, and then here you have 4, so 8.50, and then you have the value of 0.40, which you are getting from 40 multiplied by the least count. So this is what you are getting here, which is 8.90, and this is your value, corrected reading. This will be the corrected value of 4.62 if there is no zero error. Yani the zero of the circular scale is coinciding with the zero of the main scale. So this will give you the concept or idea that there is no problem as far as the you can say calibration or the correction of the instrument is concerned. But here there is another thing which you can see what is happening here. In this case, you can say and see that the line or edge of your zero, or you can say the edge of your circular scale, is not basically coinciding with zero, but it is a little bit on the right side. So when you have the right side, then what will happen? This they are saying left side because they are just you can say taking the reading flip-flop situation. This is basically the lateral image of the body. So the left of for this thing will be right on the other side. So what you can say, if basic idea is that if the zero of your circular scale is not just behind or your you can say edge of the circular scale is not touching this one, as in this case you will have a zero error, and then you will see that zero is a little bit you can say behind the actual line, or zero is not coinciding with here, but it is little bit on the downside. So what is the value? 1, 2, 3. So 3 is 3 division. When you will multiply this 3 division with the least count, you will get 0.03. So this 0.03 is termed as the positive zero error. This is your positive zero error. Positive zero error means that you are not actually using anything here, no object is here in between your spindle and the anvil, but still you have a reading. So ultimately, if you are getting the reading, what you can say here, that this is 8.93, 8.678, and when you will check this, you will get the value here, which is 4.3 multiply by 0.01, giving you 0.43, and when you will add this value in your actual value of 8.50, you will get 8.93. So 8.93 will be your reading, which is the observed reading, you can say. But as we have just discussed, that you have already taken a value of 0.03 and without using any object somewhere here, you have a reading. So what you have to do, simply you can say that this is the extra reading or extra measurement. So ultimately what you have to do, you have to subtract this value from your mean value, yani observed value. So 8.93 minus 0.03, so you will get the value which is 8.90, which is basically the corrected reading. I hope you have understood this point. The positive error will be subtracted from the observed value, and then you will get the corrected reading or corrected value. So remember this thing, that if our zero of circular scale is you can say under, you can use the word under or before this line, then you will say that the error is positive zero error, and ultimately what you have to do, you have to subtract this value from the observed value. But on the other hand, if you will see that you are fixing your instrument and you observe that without putting anything here, your zero is somewhere here above the datum line and moved above the datum line, you can say, and you have you can say adjusted the spindle with the anvil, but there is nothing in between. So without any object, if the reading is like this, so what you can say, that you are 0.03, you have moved up, so it means that always you will get the lesser value. So this is very important. Here you have the situation of 0.03 millimeter. So when you will take this 0.03 meter, of course the reading will be the less than the actual value. So 8.87 this time, this is your main scale reading. Of course, sorry, circular scale reading. Main scale reading is always same, but circular scale reading this time is not same as before. This is 35, 36, 37. So 37 multiplied by 0.01, and then you will get this value here 37, and ultimately when you will add the value which is the basic value, you will get this 8.97 8.87. So this 8.87 is less the actual value you have. So this is the situation. So what you have to do, you have to add these values. So remember this thing, when you are considering the value which is the value of the zero error negative, then what you have to do, you have to add this value, and this is something which will give you the corrected reading. So this is how you will do this. Okay, so this is what we have as far as the taking the reading is concerned. So if you have any zero error here, so you will add or subtract this zero error accordingly. I have explained this point. So remember this thing, that how you will tackle this zero error. Okay, let's move to this animation here, and this will as we have been doing in other you can say situations as well, like in case of your ruler and your vernier caliper, I have shown you animations. So we will take help from this animation this time. Here you have the screw gauge, and you can see that what is happening. So this is your ratchet you can move, or this is your thimble you can move, and inside and outside. So this is what we have here, like without taking any object in between. When you will you can say move your spindle close to the anvil, and when your instrument will be close, so what will happen, this is here something you can lock, so you cannot move now. After locking this instrument, what you can see, what you can observe here, that zero of your circular scale is coinciding with the zero of the main scale, so you can say there is no zero error here. Now of course you can unlock this thing, and we will use this object here. When you will use this object, of course you have to take your spindle back, and when you will move the spindle by using the thimble or the ratchet, then what will happen, this will be the sixth position. Again what you can do, you can lock. So during taking the reading, of course you do not have any movement of your thimble, or there is no movement of the object as well. Any object is fixed now because you have locked the whole thing. So this is what we have. And now what are the readings? So as far as the discussion of the reading is concerned, you can see here that the edge of your circular scale is coinciding with the value which is 5, and on the other hand the circular scale is giving you the value 19. So if you are considering this thing, you have to consider that what will be the situation here. So you better lock again, and we can unlock this thing, we can log again. So this is the value you are getting here. What is the value? 5 is the main scale reading, and somewhere like 14 is the value of your circular scale. But remember this thing, that this is the value which is basically giving you the division, not the value exactly. So what you have to do, multiply this value by the least count, and then you will get the ultimate result. So what you can write here, you can get like the hint show. So 5 and 0.14 is the value. So what you can say, that here we have 5.14. 5.14 will be the answer of this situation or measurement. So you can check what we have the value here, 5.14, 5.14. So here you have the value, and you can see that the value is okay. Now of course you can use different you can say sort of objects, like if you will first of all unlock this thing, take this out, and of course you can change the object, but I think you have understood what I have explained. Then I want to just show you another situation, another animation, and this is something which is coming from the here we have another, just a minute. You will see another animation here. This is showing you the whole idea that what is going on, and you can how fix the values, and of course what you can say, you can use the values, and very simply you can get the idea that if something is in between, what will be the value. So this is something which we can get another with the help of another you can say animation. Then we have another instrument here, another animation here. Instrument is same of course, animation is different. Like here you can see the better diagram I can say, and when you will fix this, you have to check that whether your instrument is with the zero error or not. So when you will fix this, you will find that there is a zero error. So what is the zero error here? 2. So 0.02 will be your zero error. Here you can see that what is happening. So this is something which will show you 0.020 error. Now you want to fix this object here, which is the lead shot, and when you will fix this, of course you will get the idea that what is the value. So here you can see that what the values you are getting. So 5, 6, 7, 7 is your value for this point. So here you have this equation of 7, and then circular scale. So what is the circular scale reading? 20, 21, 22, 23. So 7.23. 7.23 is your reading here, but you have to check what is the situation, whether this 7.23 is okay or not. This is something which we want to get the idea. 7 point, not 6 but 7.23, is it correct? So you can say that and see that they are saying try again. It means that we have made some mistake. So what is the value here? We have to check it again. Here as you can see that we have 7 is okay, here 23 is okay, but when you have zero error, then zero error was 2, so you have to check that 7.23 or 7.21, what will be the better the value or actual value you can say. So just use this thing again, 7.23, 0.03 to 21, this will be again, here they are saying check it again, yani you have taken the wrong reading. So what will be the situation? So situation is that the value is zero error, value of zero error, you have 0.02. So this time basically you have to add this value. So what you can do here, check it again, 7.23. So what you are doing here, you are taking the value here 7.25. This is fine. It means that here you have to add this reading, yani zero error was the negative zero error, that's why you have to add this time. So this is very, very important. Now here you can change the object, you can check the object. And how you can check the object, you have to reset this thing, here you have to reset this thing. And here what you can do, you can take another object like suppose wire. When you will take the wire, again first of all you can check the zero error. So you can see here that as we have taken this instrument with a zero error, which is negative zero error, and then you have to subtract this value. So be careful, add this value. This is zero error which you have to add, not subtract. In this case the zero error is negative zero error, so be careful. Now you want to fix this, and what you can say, take this back and again fix this wire, and with the help of this instrument you are getting the value. Like here you can see the value, main scale reading is not anything but 0, because the edge of your circular scale is not giving you any value on the main scale, so 0 is your basic value. And as far as the circular scale reading is concerned, it is 81 to 3, so 0.83 will be your value, and when you will add 0.02, so you will get 0.85. So let's check that what will be the value here. So let's check this value. Here first of all just remove this, and 0.85 is the value which we are getting, and it's fine. So I think you are getting a better idea that how we can get the value of anything. Reset this and you will get another chance to use another thing. Like here you are using the glass plate, so just use this glass plate, and of course you want to know the thickness of the glass plate. So this time what is the value? Here you can see that your main scale reading is 1 2, yani the edge of your circular scale is coinciding with what? 2 of the main scale, yani just behind the 2. So you can say that 2 is the main scale reading, and 61 2 3 4 64 is the circular scale division. So circular scale division, 64 multiplied by 0.01 will give you the value of 0.64. So what will be the value here when you will check this thing? So first value is 2, and you are getting 2.64, but remember this thing that you have an error as well. So 6 point, 2 point, not 6 point, 2.66 will be your value. Okay, so it's good. So 6.66 is the value which you are getting by using this whole you can say method which we have already explained. So this is another option to get, or another animation with the help of which we can understand that how we can use these you can say different objects in between the screw gauge and how we can get the idea that the use of the scale or use of the main scale and use of the zero error. So all these concepts we have already discussed. So this is what we have as far as the concept of your screw gauge is concerned. So I hope you have understood the whole story, and inshallah in the next class we will go for the other discussions. So till the new lecture, Allah Hafiz. But if you are new on this channel, so kindly subscribe this channel and press the bell icon, share this video, and of course if you like this video, you must like this lecture, and if you have any problem, just give me your comments so we can get a better understanding that whether you are getting few concepts or which we are explaining here or not. So this is very important. Your comments are very important. And of course, as I said that if you want to complete the syllabus of O level with me, you have to follow this channel, and to get this channel or new audios and videos of this channel, you have to subscribe this. Till the next lecture, Allah Hafiz, take care.